Welcome back to AI Tech Tiles. Today, we're diving into the fascinating world of data analytics, exploring the four major types: descriptive, diagnostic, predictive, and prescriptive analytics. We'll break down each type, provide detailed examples, and discuss the tools and techniques you can use to master these analytics. Let's get started. Descriptive analytics. First up is descriptive analytics, which answers the question, what happened? This type of analytics is all about summarizing historical data to understand past events. Imagine you run an online retail store. Descriptive analytics could involve analyzing last year's sales data to identify trends, such as peak shopping periods or best-selling products. For example, you might discover that your electronics category had the highest sales during the holiday season. Common techniques include data aggregation, data mining, and data visualization. You might use data aggregation to compile sales data across different regions and data mining to uncover patterns in customer purchases. Data visualization techniques like bar charts, pie charts, and histograms make it easy to present these insights clearly. The tools used for descriptive analytics include Excel, perfect for basic data summaries and visualizations; SQL, essential for querying and extracting datasets from databases; Tableau Power BI, ideal for creating interactive dashboards and detailed visual reports; Google Data Studio, great for building customizable reports and dashboards; Python, Pandas, Matplotlib, Seaborn, excellent for data manipulation and visualization; R, ggplot2, dplyr, powerful for data visualization and statistical summaries. Descriptive analytics forms the foundation of your data analysis journey by helping you understand your data story. It's the first step in making informed decisions. Next, we have diagnostic analytics, which answers the question, why did it happen? This type of analytics goes deeper into the data to understand the causes behind past events. Suppose your sales for a particular product line dropped last quarter. Diagnostic analytics would help you investigate the reasons behind this decline. You might analyze factors such as marketing efforts, changes in customer behavior, or external events like competitors' promotions. For instance, you might discover that a reduction in your advertising budget led to lower customer engagement, causing the sales drop. Common techniques in diagnostic analytics include correlation analysis, identifying relationships between variables, like the correlation between marketing spend and sales; regression analysis, understanding how different factors influence outcomes, such as how pricing changes affect sales; root cause analysis, pinpointing the underlying reasons for a particular issue, like declining customer satisfaction. The tools for diagnostic analytics include R, LM, function; ggplot2 for regression analysis and visualization; Python; scikit-learn; stats models for statistical analysis and modeling; SAS; 4. Advanced statistical analysis and reporting; SPSS, for statistical analysis and hypothesis testing; Tableau Power BI, for visual exploration and identifying data patterns. Diagnostic analytics helps you uncover the why behind the data, providing crucial insights for improving future outcomes. Moving on to predictive analytics, which answers the question, what is likely to happen in the future? This type of analysis uses historical data and statistical models to forecast future outcomes. Imagine you want to predict next quarter's sales. Predictive analytics can help you create a model based on past sales data, customer trends, and market conditions. For example, a predictive model might forecast a 15% increase in sales due to a new product launch in the holiday season. Common techniques in predictive analytics include time series analysis, analyzing data points collected over time to predict future trends; machine learning models, building algorithms that learn from past data to make future predictions, such as predicting customer churn; predictive modeling, using statistical techniques like regression models to estimate future outcomes based on historical data. The tools used for predictive analytics include Python, scikit-learn, TensorFlow; Keras for developing and training machine learning models; R, Caret, random forest for predictive modeling and statistical analysis; SAS; For advanced analytics and predictive modeling, IBM Watson Studio. For developing and deploying machine learning models, Azure Machine Learning, Google Cloud AI. For building, training, and deploying predictive models in the cloud, predictive analytics empowers you to anticipate future trends, helping you make proactive decisions that drive success. Finally, we have prescriptive analytics, which answers the question, what should we do about it? This type of analysis provides actionable recommendations based on data analysis. Let's say predictive analytics suggests a potential drop in sales. Prescriptive analytics could offer strategies to prevent this. For instance, it might recommend increasing marketing efforts, offering discounts, or diversifying your product line to mitigate the impact. Common techniques in prescriptive analytics include optimization models, finding the best possible outcome, such as maximizing profits or minimizing costs, given certain constraints. Simulation models, testing different scenarios to predict outcomes and decide on the best course of action. Decision analysis, evaluating and comparing different strategies to determine the best action based on data. The tools used for prescriptive analytics include IBM iLog, Cplex, and Gurobi. For optimization and complex decision-making, AnyLogic and Simul 8. For simulation modeling and scenario testing, Tableau and Power BI. For integrating prescriptive insights into actionable dashboards. Prescriptive analytics not only tells you what might happen but also suggests the best actions to achieve your goals, making it a powerful tool for decision-making. Each type of analytics plays a crucial role in the data-driven decision-making process. Descriptive analytics helps you understand what happened, diagnostic analytics uncovers why it happened, predictive analytics forecasts what might happen, and prescriptive analytics guides you on what actions to take. In real-world applications, companies across industries leverage these analytics to optimize operations, enhance customer experiences, and increase profitability. For example, in healthcare, predictive analytics is used to anticipate patient outcomes, while prescriptive analytics is applied in logistics to optimize supply chains. As we look to the future, the integration of AI and machine learning with analytics is transforming the way businesses operate. Real-time data processing and cloud-based analytics platforms are also gaining momentum, providing more immediate insights and actionable recommendations. If you're interested in diving deeper into these topics, check out the resources linked below. You'll find tutorials, courses, and articles that can help you master the tools and techniques we discussed today. To sum up, descriptive analytics gives you a snapshot of the past, diagnostic analytics helps you understand the reasons behind it, predictive analytics looks ahead, and prescriptive analytics offers actionable recommendations. Each of these analytics types is a stepping stone in making data-driven decisions that can transform your business. Thanks for watching AI Tech Tiles, and see you in the next video.